you have this function y equals x square root of 1 minus x. The region bounded by the curve and the x-axis is rotated through 2 pi radians. 2 pi radians mean 1 complete revolution. Remember that? Same as 360 degrees. So it's rotated through 2 pi radians around the x-axis to form a solid of revolution. Show that the volume of a solid formed is pi over 12. Okay. I want to show that it is pi divided by 12. Now, I had seen a graph of this before and saw that it looks somewhat like this. Alright? The graph has that sort of shape. So you have this area here and it's rotated around the x-axis. Now, here we can find the values of x. From the graph it looks like 0, 0, but let's confirm. Remember, the x-axis is where y equals 0. So we could say x times the square root of 1 minus x equals 0. Where does it equal to 0? Well, here we could consider it and say x might be 0, or this here x might be 1, because guess what? If x is 0, then we have 0 square root of 1 minus 0, which is 0 times 1, which is 0. Right? And if 1 minus x is 0, we have x, whatever it is, square root of 1 minus, well, it will be, if 1 minus x is 0, it will be square root of 0 equals x times 0, because the square root of 0 is 0, which is 0. So right here, x is 0. But if it is the case that 1 might, well, let me if it is the case that's 1 minus x equals 0, then what would x be? X would be equal to 1. Because if 1 minus x is 0, this part would be 0, as we saw a while ago. So it goes out to 1. Alright? Now, the shape that you would get it would look somewhat like this. Alright? Now, here, let's consider a slice of this. It would be approximately a cylinder. Let me redraw this. If it make it look more like a cylinder. It would approximately be a cylinder, right? Have the center here. Now, the volume of a cylinder is pi r squared h. Now here it's rotated around the x-axis. We're just cutting one slice of this shape. Now here, the radius. What would the radius be? You would have to, if you go upwards or downwards, you get the radius. In fact, let me go upwards for the radius. This radius would be the y value for whatever x is, right? And then the height, that's from here to here, would be that change in x, so call it delta x. So the volume of each slice, of each element here, that you cut would be, the volume would be pi y squared delta x. Alright? Now, let's call it V1, or the volume for one of them. Now the total volume, let's call it V, is equal to, alright, what happens when you put all the slices together? It would be the sum, and you're summing from where 0 is to 1. So you're summing up from x equals 0 to x equals 1 of pi y squared times that change in x, delta x. Alright? Now, that means it's equal to, now we can put the pi outside the summation. It's a constant, so we can do that. And then we have the sum from x equals 0 to x equals 1 of, well, what is y? Y would be x square root of 1 minus x is x square root of 1 minus x, and this is squared delta x. Now, it's an approximation here because it wouldn't be exact. If you slice into whatever number of pieces, a finite number of pieces, find the volume of each of them and add them up, you would not get the perfectly accurate volume. It would be an approximation. But the accurate volume, you would get that if you consider that the limit of this tends to 0. So the limit as delta x tends to 0 of the sum from x equals 0 to x equals 1 of pi y squared delta x is equal to pi by the integral from x equals 0 to x equals 1 of y squared, which is x 1 square root of 1 minus x squared dx. Okay? So you see that now. So that's what we have there. Now, I should say the volume equals here. So the volume is equal to, now it's pi integral from x equals 0 to x equals 1 of, when you square this you get x squared and 1 minus x, right? When you square the square root of anything, you get back that same thing, and then you have x squared dx. Now that is equal to pi integral from x equals 0 to x equals 1 of, if you multiply out the brackets, you have x squared minus x cubed, and then you have your dx. Now, here, what you're going to get now is pi times this x cubed over 3 minus x to the 4th over 4 from x equals 0 to x equals 1. Right? So it's going to be pi times, let's input the upper boundary, that is going to be 1 cube over 3 minus 1 cube over 4 minus, then we input the lower boundary, 0 cube over 3 divided by 3 minus 0 cube divided 0 to the fourth. This is 1 to the fourth. It's cube over 3 minus to the fourth over 4. Alright, my mistake there. Over 4. So it is pi times, well, 1 cube is 1 third, minus 1 to the fourth is done, is 1/4, minus 0, because this will amount to 0. So in this case it's pi times, and then we do some fractions here. This is 1/3, the one common denominators. If we multiply top and bottom by of this by 4, say by 4 by 4, so that we have 12 under the bottom over minus, and then for a quarter we want another 12 under here, so we multiply 4 by 3, we multiply the top up here by 3 too. So we have pi times 4 ones 4 divided by 3 fours 12 minus 3 ones 3 divided by 4 threes 12. Okay, equal pi times 4 minus 3 is 1. So 4/12 minus 3/12 is 1/12, which is pi divided by 12 cubic units. Alright, so that's what we get. So you can write that this is shown.